Hello again, and welcome to part 2 of the AVID SPOT Demo. In this part, I will load a custom pre-made scene for use in the demo by clicking the Scene menu and then selecting Load Custom Terrain. This brings up the file dialog for choosing a custom terrain input file, and I'm going to select demo.trn. Once the scene is loaded, I can switch to it by selecting Scene and then Demo City in the menu. Now, this is a much larger terrain that I'm loading right now with a lot of 3D files on it and a lot of interactive stuff, so it's going to take a second to load. And then once it's loaded, we will move on. Here we go. Okay, so as you can see, there's a lot of trees and buildings, and there was a helicopter that just flew by, so there's a lot going on in this map. First, I'm going to go over to the Capture tab, and I can see that I can create a new flight path. Let me stretch this out a bit here. A new flight path, or I can load a saved path. So that's what I'm going to do. I'm going to load a pre-made path named demo path. So keep it simple here. Alright, and you can see that it's loaded up all these waypoints. In the vehicle flight path section, I can select the demo path right here. And now when I right click on UAV, I can click Draw Path on Map. And in our map view, now we'll see a yellow line indicating the flight path of the UAV. So based on the speed of flight, Spot will automatically calculate a flight path using the minimum turning radius at that speed, the maximum rate of climb, and maximum speed as constraints for that vehicle. And now if I right click it again and click Execute Path, the vehicle will begin following the flight path. Now right now you can notice that it's looking straight at the ground. The reason for that is ducted fan UAVs have to tilt significantly when they're flying and not hovering, so I'll need to tilt the cameras upward so that I'm not looking directly at the ground. But for now I'm just going to stop executing the path. Alright. And now you can see that it's going back to its original hover altitude right above the path. I'm going to go into free flight for a second here and click the flight tab. Now these are the altitude controls, the plus and minus button. So I'm going to push the minus button here and bring the UAV down further into the city. That's probably good right there. Alright, so now I'm hovering at an altitude of 50 feet approximately. Now the reason I'm doing this is so that you can see when I target buildings, Humvees, etc. We can do a real comparison, and I really ought to fix that path because those Humvees just drove through each other, but you know, that's a user error. Alrighty, so first I'll select a target, maybe this building right here. Or actually, let's go with one that's further away, like that building. Now you can see it's targeted in both sensors. When I go to camera, and maybe I'll zoom in on it using the second sensor by tightening my field of view, and then I can, you know, tilt the camera up and get this thing all the way in my view. Oops, here we go. Oh man, there we go. And then I'll pan over a little bit as well. Okay. So now when I go to the Spot tab, we can compare the number of pixels on target in sensor 1 and sensor 2, and you can see that there's a lot more in sensor 2 because I've zoomed in basically all the way in as far as I can on this building. To sort of show you the level of detail that we can get in Spot, I will go ahead and zoom in on the street level and show you these Humvees that are driving around in more detail. Let me tilt sensor 2 down a little bit and zoom it back in even further. Oops, not that far. In a second we'll see this Humvee coming up. Alright, I'm going to target the Humvee. Actually, if I untarget, you can see that there's a license plate on the front and things of that nature. If I go back to the spot, you can really see that there's a huge difference in the number of pixels on target for that Humvee versus the Humvee in sensor 1. Same with this Humvee right here. It's just a lot more detail. But that just shows that you can have models with very high levels of detail, really as high level of detail as you can get into your .3ds file, which is what Spot accepts for three-dimensional files. Alrighty, I will now get back to the flight path here. Let me reset the cameras. I'm going to set both cameras to 50 degrees tilt, because when I start flying, it's going to tilt over again. And then in sensor 2, I will open it up again back to 50 degree field of view. Alright, now another interesting thing in Spot is the frames per second. That's very useful in sort of identifying how well you can track a target. I'm going to go back to demo path and start this path up again and draw it on the map as well. Actually, let me tell it to stop. There we go, it's drawn on the map again. Here you go, we'll execute the path again. And I'll clear my targets. So, as you can see right now, they both have the same frame rate, which is a little bit choppy. It's at 10 frames per second. Now, if I go in for sensor 2, or actually let's do sensor 1, I'm going to change this to something like 30 or 40, say 30 frames per second. And you can see that it's significantly smoother than sensor 2 is. And I can, up that even more, and you get a very smooth, high refresh rate, which allows you to, maintain your pixels on target and track it better at a higher bandwidth. That's definitely something that is worth looking at when you're designing your sensors, and so this allows you to do that as well. Alrighty. So it's flying through the city. We saw earlier the Humvees and the AVIDLLC license plates on the front. And like I said, you can generate those types of files in all these buildings and things like that using 3ds or any other program that can generate a .3ds file. And they can be textured and imported directly into Spot. And that really allows you to customize your scene so that you can, basically create the scene that you expect your vehicle to be experiencing, and get a real virtualization of that. Additionally, Spot can record pixels on target for several sensors simultaneously. This allows the user to further analyze a set of potential sensors and optimize their package based on the mission requirements and the vehicle's performance. And that Spot also has several more advanced features, such as the point performance trade study and the Spot history feature. I'll just open the Spot history feature briefly here. And what Spot history does is that it will record your history for a given target. So firstly, I need a target. Let me move this to the side. Then I'll select this guy as a target. When I say start history, it'll immediately begin recording for each target and for each sensor the number of pixels on target, and at a certain frame rate. And then I can click stop history and save it to a file. That allows me to have a recorded data on, I guess, what we've seen in Spot. So that way you can go back and parse it later and have a look at how your multiple sensors performed. There we go. And I can click save. So that's basically AVID Spot. I'd like to thank you guys for watching this demo. I hope it was an informative first look at AVID Spot. Please note that AVID Spot is cross-platform compatible, so it's available for Windows, Mac OS X, and as well as Linux. Feel free to navigate to www.avidaerospace.com to find more information about Spot and other software products, as well as any contact information that you need if you'd like to speak to a representative about any of your software needs. Thank you, and this is the first look at AVID Spot.